Hi everyone, it's awesome to see so many of you. Thanks so much for coming to this talk. Could have been any other talk, but you came to this talk. You did well. So this is me. My name is Juliadotter. I was a software developer for a very long time and developed a lot of applications that I, in hindsight, realized were horribly insecure. But oh well, that's life. Anyway, one day I started noticing all these headlines in the papers about a data breach here and there, and I don't know, I started thinking, I was like, why is that? What's going on here? And when I realized that what's really going on here is we're not writing secure code, I got a bit upset, to say the least. Like, I just feel like it's very unnecessary for world to be like that. It should not be all these data breaches. It's not that hard to code securely. So yeah, these days I work in application security, so I try to help developers understand what secure coding is and why we should do it and how we should do it. But yeah, enough about me. What about you? Who are you? Hands up those who think about security when you program. Oh, awesome, you guys rock. Hands up. Do you consider all those packages, modules, libraries, the security posture of those when you choose them? Oh, you guys are fantastic. The world will be a better place. This is awesome. So for those who didn't raise your hand, and maybe for the rest of you too, hopefully you will never look at that input statement the same again. And the good news is that you will have the knowledge to prevent serious data breaches in your applications. So it's wonderful. So who here has heard of the OWASP top 10? Lots of people. Wonderful. So OWASP stands for the Open Web Application Security Project, and they publish something called the OWASP Top 10 with the 10 most common vulnerabilities every now and then. And of course, at the top we have things like injection, like SQL injection or whatever, cross-site scripting, and coming in at number 9 we have something called using components with known vulnerabilities. And sort of what I've seen in developers in the last few years is there's an increasing awareness of security, which is wonderful. So people are starting to understand that the code they write really has to be secure. You have to do that input validation, etc., which is wonderful. But in my experience, there's a lot of sort of unawareness of this particular number 9, the using components with known vulnerabilities. So that's what this talk is about today, so you can learn a bit more about that. So let's backtrack and have a little think. What is a component? What do I mean by that? But it's basically when you do that import statement or the require or the using or whatever you use in your language, and you pull it in through your package manager. It's your libraries and your frameworks, all that stuff that goes in an application that you don't know how to write yourself. So your parsers, database connectors, your web frameworks, all that stuff, yeah? That's a component. So at least when I was programming, I used to sort of think about my app like this, like here's my app, it has my business requirements, woohoo, awesome. But if in reality, what it actually is, it's just the tip of the iceberg, isn't it, when you think about it? Because for my business logic to work, there's a whole bundle of dependencies under that. And those dependencies also have dependencies, but of course they are just source code themselves, and they pull in other libraries, right? So we need to understand that this is what our application actually looks like. We talk about something called application composition. So a typical web application today in production is about 90% components, and 10% is your source code. So that's worth keeping in mind when you think about security, for example. So let's take another little step back. So reuse of components, of course, is nothing new. It's not unique to software development either. It's something that has been done for a very long time in a lot of industries. So who here has heard of a car platform? Anyone? Yeah, a few. Like, it's basically, look, car engineers, or whatever they're called, right? They're like us, right? It takes a lot of time and energy and expertise to develop all these bits and pieces that go in a car, and you're not going to redo that for every model and every make, right? So there's something called the car platform, which has these common components that they reuse, right? So for example, we have, the Fiat Chroma, the Cadillac BLS, and the Opel Vectra C are all basically the same car, with a little bit of sprinkle on top to make it its unique sort of model and make. But while this is really good for both in software development and cars, in the sense that you're very agile, very quick to market, you save a lot of money, what happens if there's a problem with one of those components? Then, of course, it can have huge impact. So there was a whole bunch of car manufacturers that were using this particular type of airbag, right? Because why would they, invent their own airbag? They just buy an airbag from someone else and put it in. So this particular supplier called Takata unfortunately made an airbag that wasn't all that great. It was defective. And it actually killed people, and a lot of people got injured. And in 2014, a whole bunch of car manufacturers like BMW, Toyota, etc., had to recall 3 million vehicles worldwide because of this problem, which obviously costs a lot of money, a lot of reputation damage to those brands, etc., right? So question is, what happens in a software world when a component goes wrong? So let's have a little look at this clip first.
Richard Smith is really earning that pension right now, taking a lot of heat. It was a contentious hearing from the get-go, a subcommittee of the House Energy and Commerce panel taking the former, now retired Equifax CEO Richard Smith to task for allowing the private information of Americans to be stolen. Both Democrats and Republicans delivering the shellacking. Listen to Jan Schakowsky, a Democrat from Illinois, and Greg Walden, the Republican chairman of the Energy and Commerce Committee.
In the end, Equifax has had to apologize for its post-breach response almost as much as it has apologized for the breach itself. Equifax deserves to be shamed.
How could a major U.S. company like Equifax, which holds the most sensitive and personal data on Americans, so let them down?
So here is what Smith had to say for his part, an apology. Listen.
And as CEO, I am ultimately responsible, and I take full responsibility. I'm here today to say to each and every person affected by this breach, I'm truly and deeply sorry for what happened.
So what is this CEO talking about? This is CEO in the US Congress apologizing. What's he apologizing for? I'll get to that in a moment, but a bit of background information. Equifax, for those who don't know, is an American consumer credit reporting agency, right? So when an American person would go to the bank and ask for a loan, they would give all their information, and the bank would send that to Equifax, who would look up the credit rating. So for this purpose, of course, an awful lot of information was gathered by Equifax. Social security numbers, addresses, names, driver's license numbers, tag file numbers, even digital copies, photos of the driver's license and the passport. So everything you would possibly want to, for identity fraud purposes. So that was the problem. And when this data breach was announced, they lost so much money. It's not funny. This is their share price. It just plummeted. They have class action lawsuits coming out of their ears. A lot of executives had to go. Okay, well, that's interesting. But why did this happen? It happened because of a software component. I just think this is mind-blowing. There's a Java web framework called Struts. It's made by the Apache Foundation. And this is the technical description of what went wrong here. It's basically saying that this particular library, in the file upload function, that had an incorrect exception handling and error message generation, and they didn't validate the content type header, right? Now, in my opinion, any one of us could have done this, so what? However, someone was very skilled and very bored and figured out that this vulnerability was here, right? And so they got into Equifax. So this is quite interesting. This is the timeline of what happened here. So the vulnerability itself in this framework was found in February 2017. About a month later, Apache patches the problem. That's all right. It took a month. That's okay. And then a few more months pass, and then they have, investigated this forensically after the fact, of course. Turns out that sometime in May, the attackers got into the Equifax computer systems using this particular vulnerability. They relaxed, made themselves comfortable, exfiltrated all the data they could possibly want for 3 months. And then eventually, Equifax figured out that something was going on, and they patched. And then all the shenanigans happened that we just saw, with apologies to Congress, etc. So this begs the question, what is this concept of a known vulnerability that happened here? Well, it's pretty much the opposite of an O day. In Hollywood movies, they talk about 0 days and O days, and it's all very sexy. This is like the opposite of that. This is like the 1 day or the 365 day or the 2,478 day. It's when someone has found a vulnerability and it has been confirmed, it is stored in a database online. The National Vulnerability Database, the NVD, holds most of these. Don't know why they call it national, it's international, but Americans. It gets an identifier, a unique identifier, so we call about CVEs. That's sort of the lingo and the security people use, and it gets a rating of really how bad it is, from 0 to 10. So when this happens and there's a vulnerability that is introduced and is announced to the world, what happens? At some point, it will be introduced at some point because the developer of Apache in this case made a mistake. That can happen, right? But then at some other point later on, someone was bored and skilled enough to figure this out. So they discovered the vulnerability. They may even publish an exploit. And then we have this time race, which is very interesting, between the attackers and the organizations that deployed this source code. So the attackers are going to try and find an unpatched system. So if they do that before the organization finds it and patches it, they're likely to get breached. If the organization figures out, oh, drats, we're using a vulnerable component here, they can patch it and they're safe. So that's the challenge for us to stay safe. So there is a formal definition for this, I suppose you'd call it. It's called software composition analysis. And conceptually, this is very simple. It's all about making an inventory of which components you're using, which versions. Like, can you even say today which versions of which component you're using? Like, I think we're using jQuery somewhere, I don't know, probably an old version. And also the transitive dependencies, even worse, right? Okay, you use some particular framework, that's great, but which XML parser does that framework use? And then you basically just do a straight comparison to sources of vulnerability data, like the National Vulnerability Database, for example. And out comes, a list of, yes, you're using these components, these are vulnerable, these are not, this is what you should do about it, right? So, yay! I love the minions, they're so funny. So now that we understand this concept, I was thinking I should demo this idea. So let's pray to the demo gods and the Wi-Fi of the conference and have a little look. So let me show you. So remember always top 10. Now, because the world is wonderful, there are a lot of educational applications out there that will teach developers about these vulnerabilities. So there are what's called deliberately vulnerable applications, where you can learn about what the problem is, what the vulnerable code looks like in any programming language, and what you should do about it. So today I'm going to demo a deliberately vulnerable Node.js application called the damn vulnerable Node.js application. And this is on GitHub, so you can have a look at this yourself if you feel like it. And it just comes with simple instructions on what to do. So I have just forked this into my own GitHub repo, and I have cloned it for your convenience, and here it is. So according to the instructions, all I have to do is spin up the Docker container, like so. Building database, waiting for something, and it worked! Hooray! Okay, that's a good thing. So let's have a look at our wonderful application. So here it is. We need to log in. Let's do that. And yeah, so for whichever vulnerability you want to play around with, here they all are. So we're looking at number 9, using components with known vulnerabilities. Click on that, scroll down, and there is a calculator scenario they've given us here. So here is a simple calculator. Some developer has thought, oh, let's write a calculator, we need that. So, you know, and they're assuming, we can see this clearly from the sort of default input here, that they want some numbers and or special characters that will make sense from a calculator point of view. So let's just check that this works. So 6 times 7 is, yes, 42. Hooray, meaning of life. Awesome, this works. Okay, that's good. However, what if you're not so nice? Not all users are nice, you know. Someone at some point figured out that if you put this string in instead, as you would, right? Anyway, you may not get 42, you might get something else. Oh, that didn't work. Let's try that again. Copy, paste. So, yeah, to recap, what this horrendous string is doing is it's whatever is in this little last bracket here is a command that it will execute on the operating system, which is a bad thing. Okay, not intended. So here we're asking for ID. So for example, if we go to, for those who are not familiar with Linux or whatever, like the ID command will just show you who's running the particular process you're using at the moment, right? So that's the idea. So if we execute this here, turns out, yeah, because I'm running the Docker Composer sudo, oops, here we go, we're root. Okay, that's a bad thing. So at this point, we know that we have remote code execution on a machine because, yeah, okay, I'm running this locally, but hey, you know, I could be on the other side of the world, right? So your imagination is really the limit of what you can do here. So we can look at FAS, for example, just to point that out. What should we look at? This one's usually popular, the Etsy password. Will that work? There it is. Okay. So, you know, you can obviously do really malicious stuff like, I don't know, you could shut down the server, or you could just, you know, delete the whole machine, or, you know, figure out the database connection string and grab data, or, yeah, you know, you can think of evil stuff to do if you're evil. So the reason this is happening here is the application uses a library called math.js. Here it is. So we go var math.js require math.js. And then when we hit the submit button, what it's doing here is it's calling this calc function. It's just sending the request body to the eval function in the math.js library. So there's your problem. Okay. All right, so now we're all terrified. What should we do about it? Well, good news. Where there's a problem, there's a vendor who wants to make money. So let's have a look at one of these products for software composition analysis. There's plenty around. I'm not saying I recommend or like or dislike or whatever this one, but it works, right? This one is called SNCC. Use open source, stay secure. A developer-first solution that automates finding and fixing vulnerabilities in your dependencies. Well, that's just what we need, isn't it? That's wonderful. So let's have a little try here. So let's log in to this thing. And I'm just going to use my GitHub account, because why not? And I'm gonna have to find my password. This is a bonus demo. Always use a password manager, because you only have to remember one password ever. And all the other passwords used for all the million sites you log into can be long and unique, which is wonderful. Anywho, it's just pretty pragmatic too. Okay, so I have no idea what my password is for GitHub, but here we go, I can log in, so that's good. So here's Snick, okay, that's nice. So depending on where our application is, we can integrate with whatever. We have GitHub, Bitbucket, Heroku, Stuffy Stuff, Artifactory, whatever. So my stuff is in GitHub, so I'm gonna do that, and then it says, okay, which repos would you like to test? I say, okay, I'd like to test the DVNA repo, because that's my problem. And I click add this to Snick, and it goes, okay, I'll have a little think about that. And what it's doing now, it's analyzing the dependencies. As I described before, it's analyzing the dependencies that are in the project and comparing that to its source of vulnerable components. And here we have the result that was pretty quick. So it has had a look at the package.json, which is where you declare the dependencies in Node. If it was Java, it would be a POM, or yeah, you get the idea. And it has found 4 high vulnerabilities and 3 medium vulnerabilities. Interesting. So we can have a look at this report. Ooh, arbitrary code execution. That's a bad one. All right, there's lots of that. That's basically as bad as it gets. Arbitrary code execution is like, the attacker can just execute commands on your operating system that runs the web app. It's a bad thing. So we have some more information here. It says, well, the vulnerable module here is the mass.js module, and for these particular versions, it's vulnerable. And what I should do about it, more importantly, is upgrade to this particular version. So that's nice to know. So, because I'm lazy, I'm not going to go and do that manually, because that doesn't work with my fully DevOpsy, automated pipeline. I'm going to ask Snick to make a pull request for me to fix this. And I can choose which ones I would like to fix. It also informs me that there are only fixes for 5 of the 7 vulnerabilities. So yeah, it's not perfect, but if there's no patch, what can we do, right? But it's good to know, at least. We know that we're vulnerable, which we didn't before. So I'm going to say, yes, please. I'd like to open a pull request for this. So it will generate this for me with a lovely description and comments and all that, and it's doing some checks. All checks have passed. Woo! I say merge, and it generates a comment for me, so all I need to do is click the green button. Lovely. So here we have a fixed app. Well, that's cool. Let's see if this actually works. So if we go back here and close the app, stop the app. There we go. Let's do a git pull to get the, not git pull, git pull. There we go. Okay, now we have the latest version, that's nice. So if we then have a look at what we've actually done here, it's head, hang on. A little funny one, and head again, I believe. Yes, there we go. So the change that Snick has made for us is it's just upgraded the mass.js library from this vulnerable version to the new version, which is not vulnerable. So that's nice. So let's spin up the app again and see if this has fixed the problem. Docker compose. Wait for it, and it worked. Okay, cool. let's go back. So let's go back to our little app. Here it is. Log in. Lovely. No, thank you, but thank you all the same. And go back to our number 9 and our calculator. Let's just say we haven't broken anything to start with. So 6 times 7 is still 42. Yes, that's good. So let's enter our horrible exploit code once again. Oops. Okay, here we go. Submit, and boom! We have a stack trace, which I know looks bad, but okay, in this context it's not. Okay, it's bad because we're revealing information about the system that we shouldn't. But my point is we've fixed the particular issue we were trying to fix, at least. We cannot anymore execute commands on the operating system. Yay! So that's a good thing. Am I going for time? Pretty good. Okay, cool. So let's go back here. So now that we know sort of how the idea of software composition analysis works, I've had to go through the process of choosing a suitable tool myself. So I'd like to share a bit about my experience of that. Obviously, you'd have to pick a tool that covers your particular language, right? So if you're using Java or Node or .NET, something then with your dependency manager as well. It comes with the language, you know. So if you're using NuGet or Maven or NPM or whatever, yeah, obviously make sure it covers that. And any other tools that you're using, like build tools, a lot of these software composition analysis tools can hook into your build pipeline. So it just depends on what you're using and what you need. So there's usually a plugin for Jenkins, TFS, you know, Bamboo, all of those normal tools. So just double check that it's compatible with your particular tool chain. And also have a little think about sort of where in your software development lifecycle you would like to put this capability, because like in security, we often talk about shifting left, meaning, you know, find the vulnerability as soon as possible. Because, I mean, imagine if you're programming in your IDE and you need to, add a new library, and your IDE tells you straight away, "Whoa, that's really dangerous. Don't do that." You'll be like, "Oh, okay, no worries," and then you pick another one, and that was the problem solved. Compare that to Equifax, right? The worst case scenario. It's in production, and you're getting hacked, and it's horrible, and it costs so much money. It's not funny. And then you have sort of everything in between your IDE and your prod environment. So your source code management system, like GitHub or Bitbucket, your package managers, that's what I've talked a lot about already. Your build CI, CD, pipeline. If you're using a binary repo like Artifactory, there's usually nice little plugins for that. Artifactory even comes, like the enterprise version even comes with its own solution called X-Ray. So you may even have it for free for all you know. Or your QA tools. It's also quite handy to look at production to see what you've got there, because it gives you an accurate sort of picture of the security posture of your application, at least from the components point of view. So you can make educated decisions about risk, like, do we want to keep this framework, or is it worthwhile spending the time refactoring our entire app because it's horribly vulnerable, or are we willing to take the business risk? Yeah. And while I'm on that topic, it's not only the phase of your software development lifecycle that you need to think about. What are you going to do realistically when you find out how horribly insecure all your dependencies are? You probably have already some sort of defect management system in your organization. So maybe you're using Jira or whatever, right? So a lot of these systems are very automation and DevOps friendly. So you can, for example, just generate Jira tickets and assign them to the relevant person and relevant sprint or whatever. But to be honest, the best way to stay secure is really to continuously update. I don't know about you guys, but like when I was developing, a lot of the times, like you get your dependency to do whatever you needed, and then you put it in there, and then you never looked at it again. 2, 5, 10 years later, oh, it's still there. It's still jQuery version, you know, something very low. Because why wouldn't? Because why? Like, you know, you're busy. You're writing business requirements. You don't have time to look at, you know, updating versions of components. But it's probably worth continuously updating. Work it into your process. Put it into your, make tasks, make stories. Always keep up to date. Because updating, as you all know, I'm sure, like upgrading a major version number of something, it can be, yeah, difficult, expensive, regression testing galore. Oh, don't want to go there. So just thought I'd round up with basically summarizing this. So I'm saying, please go ahead and use open source components or closed source or whatever. Like, use components. It's brilliant because we need to be agile and productive and get to market quick. But don't be naive. Don't expect these components to be secure. They may not be. They may be wonderful or they may be horrible. You don't know. So do check for known vulnerabilities. If you're super paranoid, you can even check for unknown vulnerabilities using static analysis tools, but that's a different talk. But yeah, just don't be naive. Always assume the worst and automate everything. To be honest, that's the only way you're ever going to keep up to date and keep secure. You have to automate everything. If you rely on a manual process, it's never going to happen. Okay, and that was really all I had to say about that. And I'm super happy to take any questions you have. Yes.
This snake tool,
Yeah.
is it working with Bitbucket when you are on premise or just
Good question. Bitbucket. So the question is, does Snyk work with Bitbucket on-prem? I don't know off the top of my head. Integrations, Bitbucket. Right, Bitbucket server or Bitbucket? So possibly, I guess is the answer. Yeah. So as I said, I've spent a lot of time comparing these products, and yeah, there are other tools. There's one tool called Black Duck. There's another tool called White Source. And basically, when you pay sort of more money and go more high-end, you get more integrations for your money, more ready-made integrations. They're usually very integration-friendly anyway. So if there's an integration you would like and it doesn't have it, you can usually write it yourself. But if you don't want to do that, you can buy like a fancy state-of-the-art solution that will integrate to just about anything you could ever want. Yeah. So this picture that I showed before with the integrations, this one is from Black Duck, FYI, because they cover all these tools. Right. It also costs an awful lot of money, but you know, Snyk, I have an account. I've never paid for it. I just used it now. I just logged in and used it. Right. So yeah. Any other questions? Yes.
What about your containers, such as these operating system vulnerabilities as well?
Yep, absolutely. So the question is, what about the containers? And that's a very good question. Some of these tools do containers, and some don't. It's certainly a known problem to these vendors. I know Black Duck, for example, they say that yes, they do support scanning containers, but I haven't tried it in anger myself, so I can't say if it's good or bad. Then we have specialized container security scanning companies. There's one called Aquasec. There's another one called Twistlock, that specialize in security for containers. And I believe X-Ray is really good as well at really introspecting every nitty-gritty little detail of your binary. So if you give it a container that's a binary, it's gonna find what's in there. Yeah. Any other questions? Yeah.
What's the name of the product category of these dependency scanners? So
Yeah.
what can I Google for?
Yeah, exactly. What to Google for? Very good question. So basically, if you Google for software composition and analysis, that's what you want. So here you go. You have white source, Sonatype is also playing around in this market. Veracode, Flexera, Gartner has, reports about this. Here's Black Duck that I mentioned. Yeah. So software composition analysis. Any other questions? Yes.
So what's your experience on bridging the discussion between security teams and development teams to make sure that everyone is on board, so developers have a chance to run those patches, because you have to bucket JSON updates when you're on the far on the left side, right?
Yeah.
But then you have security teams that are sometimes more conservative and they don't know what's going on necessarily.
Yeah, exactly. No, the common. So I sit in the central security team where I am now, and I talk to developers. And a typical conversation is, I will say, hey, you have all these security problems here, you need to fix them. And they say, oh, regression testing, it's going to take too long, right? So I agree with you. There's always that contention. Of course, you have to be realistic, too. Ultimately, I think of security as part of a quality aspect. It's a non-functional requirement that a good developer is interested in, and you saw that with people raising their hands here. That, people developers who care also care about security, in my experience. And if it means keeping your components up to date, then, in my opinion, there should be an interest to do that. Yeah, look, larger organizations will also have, sticks that will have policies and standards and process, so we can always enforce that and say, no, your application is too vulnerable. You can pen test it, or you can penetration test, which is when you act like a hacker but you're employed by the company, and you can, if you find vulnerabilities, you can say to the developer, look, here's your problem. Your application is vulnerable, and we're talking about the developer's baby here. So hopefully they will be like, oh no, that's terrible, and they want to fix it, right? So I don't know. Does that answer your question? It's a tricky topic that we could, probably spend hours and lots of beers talking about. Yep.
One experience I've had is we've got tools, multiple such tools that look at dependencies.
Yep.
My security analyst went and said that it's scanning the version in your packet JSON through different databases.
Yep.
Which is great.
Yep.
But then he asked, what about dependency of dependencies? He once did do a listing and list of that, of all dependencies. And he said, well, for one depth, there's 1,024 dependencies.
Yeah, yeah.
If I do a search of this one today,
Yeah.
in the CVE database, it'll spend some X amount of hours. It's impossible for me to do it next week and next CI role and next CI role. It's just plain impossible.
Sure, right.
We don't have a solution for the problem. Have you seen anything that solves this?
Okay, so the question is, what about transitive dependencies, and it's too hard to update everything? Sorry?
Yeah, or keep maintaining.
Yeah, to maintain everything, yeah. Oh, look, I don't know I don't have a silver bullet. I suppose, yeah? Do you want to comment on that? Yeah.
NPM has a silver bullet right now.
Oh, brilliant. There you go.
In NPM version 6.0, they introduced NPM audit,
Yeah.
which you can use to scan all. It will automatically scan all the dependencies that you install. And I think in NPM 6.1, they introduced NPM audit fix or something like that, which actually does what Snyk does. It updates all the dependencies.
Yeah. Oh, great.
Weird transitive.
Nice. Yeah, I mean,
He didn't believe that he actually did that, and then he did a check against certain other databases, and he wasn't happy that it missed
It missed stuff.
clarity.
that's one of those, yeah, that's a quality aspect that you will really only find out sort of once you have already committed to a solution generally. Like, yeah, who knows, all these different products and vendors, and maybe some of them do transitive dependencies really well and some don't. It's probably worth investigating. But wasn't NPM audit, wasn't that acquired by someone and now you have to pay for it or something? Just worth.
No, I don't think so. I think they had NSP. It was
Oh.
a product
Oh, yeah.
that came out of
That's right.
security, and then
Yeah.
they moved it into NPM.
Yeah. And there's also in GitHub itself, you can get some reports on the security stance of your vulnerabilities, which is also good. Yeah. So think we're running out of time, but super happy to take more questions, sort of, after or offline or whatever. And yeah, thanks so much for coming.